Sorry, mic check. Now look at these things. Don't these look fun? Combinatorics, combinatorics, combinatorics. Okay, it does say 2 viewers. Normally that's just a glitch and it's gone. Okay, I can only go till 8:30 because there's this special teacher broadcast thing that I have to watch. So pretty much we'll just get through as many of these as possible. And I have looked at all of them, and this is it. We're done after that. And we would have answered every band 6 question ever asked in extension. And remember how we had that question before where it was like it had 2% and 3% of people getting it or something like that? This one is even worse, like the very last question. Okay. Anyway. All right. So, 2 players. Let's do this. Doesn't this just look disgusting? No, this one's actually not that bad. It's the last part that's a little bit weird. There's a lot of algebra involved. Okay, so 2 players play a series of games to get a prize. In any game, either of the players is equally likely to win. So it just means I've got a 50% chance. I'm really glad that the trial was cancelled because I would have no hope. In this, it was, yeah, the last 2 questions were hard, weren't they? Okay, so to begin, oh my god, go away. To begin, the first player who wins a total of 5 games gets a prize. Okay, so they play a bunch of games. Whoever wins 5 games gets a prize. So I guess one thing you can take out of that is the maximum amount of games they can play is 10. So 9, because they can win 4 each, and then the next person wins, so 9, and that's kind of helpful for the next part. Okay, so they've got to win 5 games. Explain why the probability of someone getting the prize in exactly 7 games is that. 9, yeah, sorry. Yeah, 9. Is that what I said? I think so. I think I corrected myself. Okay, get out of my face. So, let's set this up, eh? Question 21. Hi. Alright, so the probability of them winning exactly 7 games. So you've got to think about what scenario that would happen. It's kind of like they would win. So I guess if you think about 1, 2, 3, 4, 5, 6, 7. If they want to win in exactly 7 games, they have to win this one. So like they have to win the last one. Because if they went win, then it would be over and it'd just be 5 games played. So they 100% have to win the last one. And there's a half probability of that happening because of they're equally likely to win. So no, so it's not quite that, but very close. So then you do the binomial theorem on this lot because they have to win the lot. That's like the condition. X equals 5. Probability that X equals 5. Yeah, essentially, yeah. So then it's, no, probability that they win 4. So you think of this as an independent event. Oh, it is dependent, but not dependent, if that kind of makes sense. So it's X is a binomial distribution of 6 games with half probability of winning, and P of X is equal to 4. Does that kind of make sense? And then you times it by a half. So you're timesing it by this probability. I hope that makes sense. So then it's 6 choose 4. It's a show that question as well, so you know what you're aiming for. 6 choose 4, a half times 4 and then a half, to the power of 2. So that's 6 minus 2, and then, what am I saying? 6 minus, yeah, and then times it by a half. And then that's 6. Actually, I should write it how they write it in the question. So 6, 4, a half, and then that's 4 plus 2 plus 1 is 7. I hope that makes sense. So that's a first. That's only 1 mark as well. And the next one's only 1 mark too. This is terrible working out, but well. Okay, the second one. So write an expression for the probability of someone getting a prize in at most 7 games. So it's kind of like the language is the hardest part about these. So you think about at most, what kind of scenarios could occur. So you think about the probability that they win. So in at most 7 games, they could win in 5 games, which we kind of looked at before. So in at most 7 games, that's the same as the probability that they win in 5 plus the probability that they win in 6 plus the probability that they win in 7. Does that kind of make sense? Because you're like, they could win in 5, or they could have lost 1 in here and then they win in 6, or they could have lost 2 and they win here in 7. 1 to 8, 9. No, I'm stupid because I forgot a plus C yesterday and that was extremely annoying. I hope that makes sense. Does that make sense? So then it's like they've already given you an expression. So if this is probability in 7, like we already have that. So this one is 6 choose 4, 1/2, 7, and then you can kind of just go back and like this one they would have played. Is that right? They would have played 1 less game. So 5 choose 4. The only question I got wrong was due to time pressure. I got the first one wrong because I didn't realize it was only 7 seconds. So 1/2, 6, and then this one is 4, choose 4. I hope that makes sense. So in this case, they have to win the last game, and then the other 4 are up to... there's another way of writing this first one, because they could just win all of them. So really, it's just... that'd just be a half to the power of 6, would it not? Because 4 choose 4 is just 1. So that one's a little bit different. But yeah, they play the first 4, they win the first 4, and then there's an additional half that was out here. And that was to the power of 4. That makes sense. All I was doing was using this in 7 and just changing the numbers for these. Anyway, just so you know, yesterday limits are not in the advanced course. So when she said that, that was completely false. Because I looked it up in the syllabus afterwards, and I'm certain that it's not in the syllabus, even though she said that it was. Okay, suppose now that the prize is given to the first player to win a total of n+1 games, where n is a positive integer, by considering the probability that A gets the prize, prove this thing. Okay, so this is the band 6 part. The first 2 parts aren't that bad. It's this part that's a little bit tedious, and I think it's pretty mean that it's only worth 2 marks too. Oh, while I do this, do you reckon, would you want to go through that paper in next term? Like during these hours? Oh. Yeah, so did I. I didn't like that she was calling them out and then they weren't saying anything and then she kept trying to do it the whole time. It was kind of awkward. Anyway, so these questions aren't too bad because they show that, but still, it's kind of, it relies on a little bit of thinking. When would we do it? Like week 1 and 2, when you're not here because of lockdown. Week 1, 2, and 3, and then you come to school week 4 or 5 for year 11. Oh, but you're in year, I don't know, next term, like during this time, because we're out of questions, kind of thing. What was I doing? Oh yeah, so this is what I was talking about in the last question. So the prize goes to the person that wins a total of n+1 games. So you kind of got to think about, aren't you not allowed to do a lesson? Do you mean like, I mean like in the same format as exactly what we're doing right now, but instead I'll just go through the test. And in terms of extension 2, you're allowed to do that by yourself. What was I just doing? Okay, so the prize. So this is kind of what I was saying before. The prize goes to the first person who wins n+1 games. So suppose the prize given to the first person that wins a total of that many games. Before it was a total of 5 games. Now it's a total of n+1 games. They haven't told you what n is. Now it says considering the probability that A gets the prize, so whatever, it's kind of like going through each scenario. So kind of like the last question was like if the goal was to win 5 games, then they could win in 6 of them, or if they could win in 7 of them, or potentially they could win in 8 or 9. Greg told me he doesn't think his work ethic is high enough to do that. Yeah, well that's fine. It's better off doing well in extension 1. You've got it good because you've already done both courses. Like you'll just be doing extensions and that's it. Whereas anyone else that's not accelerated would be doing all 3. So I totally understand that. It's going to be really good for you just doing the one course, because you could spend essentially 3 courses worth of focus on one course. Oh, is he really? Okay, I didn't know that. I need a message for Sankey. Quang's still keen. That's interesting. What's he like? I've never really spoken to Quang before. Okay, so the prize is given to the person who wins n+1 games. So you've got to think about the maximum, like what's the smallest amount of games that he could play to win. So he could win straight up n+1 games. He could win all of them straight away. Or he could win, what's the maximum amount of games that they could play? Well, it'd be, if you think about before where it was, they have to win 5 games. 5 plus 5 is 10. You take away 1, that's 9. That's 9 is the maximum amount of games they can play. So it's kind of the same with this. So the minimum amount of games is n+1, because he could just win all of them straight away. The maximum amount of games is going to be n+1 plus n+1 minus 1. I hope that kind of makes sense. So suppose I win all of them, and then you win all of them less 1, if that kind of makes sense. So then that's 2n plus 1. So that's like the maximum amount of games that they can play in total. So it's the probability that they win in at most, and so I'm kind of using the same language as before. Before it was in at most 7 games. This one's going to be in at most 2n+1 games. So I feel like there's a lot of setting up to this question, just not even using the maths, but just kind of thinking about it. Okay, so then you've got to kind of write an expression for this. So you just use what you're thinking about. Well, I guess what I was thinking about here. So underneath, I'm just going to write. So let's suppose that I win n+1 games. What would that look like? Well, back here it looked like I play 1 less and I win 1 less. So I play 1 less and I win 1 less. So I'm literally just following this. And it was to the half n+1. So instead of 5, it's n+1. Is this making sense? Okay, and then I win, perhaps I win in n+2 games, blah, blah, blah. And then perhaps I win in, that's the maximum amount of games. So this will be n+1, n+1, is that right? n+1 out of, oh no. Because it never changed. I was always doing 1 less in the amount I want to win. Does that make sense? 1/2 n+2. 2n+1 n 1/2. The person from yesterday said they graduated last year, so they wouldn't. Yeah, that is exactly what I was thinking. I think because some teachers must spend a lesson on limits, even though it's not in the course, just so then the students kind of get an idea of what they are. I didn't do that. I probably should have, and I'll probably do that next year. But that's the only thing I could think of. I was thinking the same thing, like she would have done the course, so she should know what's in it. Because it was fine for the bloke that did the extension one, because he graduated a couple of years ago, so the course would have actually been different for him. But it was interesting that she was going over oblique asymptotes because that's not a thing at all. Like the word oblique isn't in the syllabus at all. Or what else do you even call them? Diagonal asymptotes? That wasn't in the course when I did advanced. So anyway, okay. So then it's basically just this expression, and we're trying to get to all of this junk. So I guess if we just start, I'm going to move this because I'm running out of room. In addition to that, this is going to kind of seem weird, but the probability of this occurring, so the probability of this person actually winning, and you can see that on the right-hand side here, it is an equality, and I'm sitting here with just an expression. The equality is that he actually has, what does it say it? Each player is equally likely to win. So no matter how many games they play, it's always going to be the case that they're going to have a half chance of winning. So any expression that you come up with will always, or should always be equal to a half. Which I don't know if that, I don't think that makes, I don't think what I actually said makes sense, but I think what, in terms of this expression, it kind of makes, like, obviously this isn't going to equal a half, but I don't know, I haven't typed it in, but it should, actually that's curious. I wonder if that equals a half. Surely not. I don't want to sit there and type it in. Anyway, so it's just a matter of making this thing look like that thing. And you can see that I've got halves to the power of things, and they've got twos to the power of things. So you can kind of just turn these halves into 2 to the power of minus 1s. And I need the right-hand side to look like 2 to the power of 2n. So that's the first thing that I'd want to start with. So 2 to the minus 1, I want that to look like 2 to the power of 2n. So I need to multiply. So I need to multiply by 2 to the power of 2n plus 1, because then they're going to go, no, 2n plus, all right, 2n plus 1. And then yeah, that makes sense, yeah. So then on the right-hand side, I've just got 2 to the 2n, which is what I want, but it just means, oh, did you type that in? That was quick. Okay. Anyway, okay, so I have what I want over here. So that just means I need to turn each of these terms, or multiply each of them by this thing. So then I'll try and simplify as we go, but I've got n, and then I'll turn this into a 2 minus. I hope that part makes sense. So I just remove the half, and then I'll times by 2 to the 2n plus 1. So there's so much algebra involved in this thing. N plus 1, and I'm running out of time very quickly. 2 to the power of minus n plus 2. And then I'm going to times that by 2 to the 2n. Can you see why this is a really mean 2 marks? Already run out of room. Also, I don't actually know if you're allowed to bring a stapler into the exam. I asked about that, and they seemed to think that that was a really strange idea. Okay, what have I got here? I'm going to have 2n plus 1 minus n minus 1. 2, okay, so 2n plus 1 minus n minus 2. I think the chances are very, very low that anyone's going to lose your paper. Okay, so then this is n, and that goes, that's going to just be, oh, I've forgotten to write all, I forgot the 2 in this one. 2n, is that what I'm left with? Yep, okay. Then this is 2n minus n, so n minus 1. Is this the expression I want? Yeah, it is. Bye. That's just 0. No, that's just 2. 2 to the power of 0, which is 1. Should that not be an n plus 1? 2n plus 1. Oh, you idiot! It's 1. No. Yeah, it's 1 less. That should just be 2n. I need to get rid of that. That should be that. God damn it. Alright, but that's it. Why do we know it's equal to a half? I don't like this either, but that confused me as well, and the only justification anyone gave me was this literal sentence up here that it said they're equally likely to win. So I don't know, to be honest. I was also slightly confused as to why this is a multiplier by a half. I kind of understand that. I don't really understand why the whole thing's equal to a half. Then why isn't see that's my argument. But maybe if you were to use this expression to answer this, so if you let n equal 6, so then it's 6 plus 1 is 7. So if you let n equal 6, maybe this expression equals this expression. Maybe that's like a formula for these questions, because this is essentially at most how many games? This is at most 7 games. So I think that's part of the reason why. Any further than that, I'm not sure. But I'm pretty sure only it was a really low percentage that got this one. Okay, 22. Now, this question, I don't actually... I think this was the question that was done really poorly. Let me check. Yeah, look, only 9% of people got that last part. 2 to the power of 6. 2 to the power of 2 times 6. Oh, was that what that ended up? Where is it? Yeah, you'll notice that every single one of these questions is the last question in the exam. Yeah, okay, so this next part, only 11% of people got right. Okay, I'm gonna have to fly through this. I've got 5 minutes. Okay, let's do this one. This one can be kind of confusing. So, two people play this game, and then there's like all these scenarios for which someone wins, and it's 5 marks. So what? 10? Not even 10 minutes sitting there playing with this. But there's a spinner. There's 3 sections, and then the probability of each section is just the lower case. So like if they roll a p, it's little p, little r, little q. So the rules are, if it's your go and you stop the spinner on p, then you win. If it's your go, you stop the spinner on q, then the other person wins. And if it's your go and you spin it on r, then it's the other player's turn and no one wins. So there's a couple of scenarios where you might win, and they all kind of need to be taken into consideration. So show that the probability of them winning on the first or second term is this. So you're required to prove that A wins, and we'll just call it T1 and T2, on turn 1 or turn 2. So that implies addition is equal to 1 minus R P plus R. Okay, so you just got to think of all the scenarios where they could win. So the easiest one is just if they straight up roll a P. So probability that A wins on turn 1. So how is that possible? Well, that would just be he spins it and he gets P. So spins it, gets P, that's it. Now the probability that they win, so A wins on the second term, I'm going to need a little bit of space. So the probability that they win on the second turn is a little bit different, because if it starts as their go, and then they spin it, they can't win on their first go. So the only way that they can win is if they not. So there's only three options. They can. Why am I pointing at it? Let's go to here. If they spin this, then they win straight away. But for them to win on their second go, they'd need to relinquish their turn. So in other words, they roll an R, and then the next player rolls a Q. So then I win. So pretend that I'm A and you're B. So let's suppose I roll this one. So now it's your turn, and then you roll this one. So then I win on the second turn of the game. So I hope that kind of makes sense. So in other words, the way that I win is if I land. So probability that A lands on R to relinquish my turn, and then you land on Q. So then I win. Does that kind of make sense? It's kind of weird. So if I land on R, the probability of that is R. If you land on Q, the probability of that is Q. I don't know why I put a dot there. So then the probability that they win on T1 or T2 is going to be P plus RQ. Hope this is making sense. Now, the thing I'm trying to prove doesn't have a Q in it, so then I need to kind of get rid of that. So another way of thinking about Q is obviously each of these have to equal 1. So then like P plus R plus Q equals 1. So that means Q equals 1 minus, let's just do minus P minus R. If that makes sense. 1 minus P minus R. 1 minus P minus R. Now, if you think of this question's slightly confusing just because the last thing is factorized, like what you're trying to aim for is factorized. So there's one thing you could do is just expand. You could expand this, so you could just be in your required approved line, just expand it. Or if you actually left it written like this, so 1 minus P plus R, and then P plus R minus R outside of P plus R, you can see you can factorize in groups. So it's like this. So then you can take a 1 minus R, P plus R out. So then it's a little bit more obvious that this thing factorizes to this. But if it's not that obvious, just obviously expand that, and then you should be fine. But it just takes a little bit to expand that because you'd probably need FOIL, because I definitely wouldn't be able to do that in my head. Okay, the last part. Oh, it's 8:30. I'm going to be late. It's okay. It's okay. Oh, actually, I like this question. I think you'll like this question. So the probability that they eventually win. So think about all the possible things that could happen. Like if you and I were playing, I could roll an R, and then you could roll an R, and then I could roll an R, and then you could roll an R, and this could just go on forever, right? So it's the probability, and I think the term eventually, or the fact that this could go on forever, kind of implies. No, that's right. I think that it kind of implies that you'd be looking for some sort of end of a geometric sequence. So, no, I think this is a cool question. We'll do it. All right, so we're required to prove that the probability that is it A? Yeah, A eventually wins. A eventually wins. So I guess you just got to think about all the possible scenarios. So is it 1 plus R? Okay, so it's the probability that A wins. So the probability that I win on some given terms, like turn N, or just think of it like T1 or T2, which we've already calculated, or T3, or blah, 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 forever. So that's the goal. So then it's weird because each second turn, it's not my turn, if that makes sense. So like, let's suppose I start. The probability of me winning on turn 1 is this. So that's T1. I'm going to go over each one. So the only way I can win on turn 2 is if I relinquish my turn and then you lose. Does that kind of make sense? I hope. And then on turn 3, the only way that I can win that is if I relinquish my turn, then you relinquish your turn, and then I win. And then on turn 4, the way that I would win is if I relinquish my turn, you relinquish your turn, I relinquish my turn, and then you lose. And then keep on going. Does that make sense? I hope. So I can simplify that, obviously. So you just got to get used to your P's and Q's. Okay, and then you can factorize these. So I'm going to do it over here. So everything with a P in it is going to be 1 plus R squared plus R4 plus blah, blah, blah. And then I can also factorize an RQ. So then I've also got 1 plus R squared plus R4 plus blah, blah, blah. And then I can factorize in groups. So 1 plus R squared plus R4 comes out. And in the other brackets, there's a P plus RQ. Now, I already know what P plus RQ was. That was from the last question. So just like P plus RQ was this. So I know that it's 1 minus R, P plus R. And this is a geometric sequence. So A is equal to 1, R is equal to, well, R squared. It's getting multiplied by R squared each time. So then I can find the limiting sum, so S infinity, and I can see at what value would I eventually end. And it's A on 1 minus R, which is 1 on 1 minus R squared. And then so this thing becomes 1 on 1 minus R squared times 1 minus R P plus R. And you want it to look like that single fraction up there. So I just put that thing on top, so 1 minus R P plus R on, and obviously something's going to cancel, and you can see there's a difference of 2 squares on the bottom. So 1 minus R, 1 plus R. There you go. And I'm left with P plus R, 1 plus R. That's required. I think that's such a cool question. Yeah, you said it. It's such a mad question. It's so clever. I really think that's a really beautiful question. Anyway, I do have to go, but we've got one more question, so that's kind of exciting. And it is, I was looking at the statistics, like at the bottom of this document. This bottom question, only 2% got right, and it's the worst question ever asked. And remember that question we were doing with the one that we realized was an advanced question? Yeah, that was the same year. So if you did advanced and extension 1 that year, then you would have got destroyed by that last question. So this one, so 2010, and then you would have done your extension 1 test and been like, oh, now I've got to answer this thing, which was, again, one of the worst. But yeah, okay. Have a good holiday. I guess that's it. I'll see you Tuesday, week 1, so in like 2 weeks. And yeah, let me know if you need anything. Let me know if you need any more papers, or if you want a hand with a paper, or if you want me to go through one, or if you have any questions about any of them. But yeah, sigma notation. Yeah, well, that's another thing that used to be in the course. Maybe that's why it's slightly confusing. Oh, it's actually a bit of a stitch-up question too. I'm pretty excited to go through that because it's terrible. All right, goodbye.